morning, all of you. Today we are going to learn continuation of integers. Okay, in this session we learn about integers. Okay, properties of integers, that is closure property, commutative property, associative property, identity property. Okay, first we look into the properties of addition. Okay, closure property is satisfied for addition, that is adding two numbers always result in an integer. Let's look into an example. If suppose I1 is an integer, I2 is an integer, the result I3 is also an integer. That we say when we add an integer to another integer, the result again will be an integer. Okay, for example, if we add 2 plus 3, the result is what? Yes, 5. 2 is an integer, 3 is an integer, again 5 is also an integer. So addition, closure property, addition is satisfied for closure property. Then comes commutative property. Here the order of addition does not affect the sum. Means, for example, if I1 is an integer, I2 is an integer, then I3 is also integer. If we change the order as I2 plus I1, then we get the same result. That is, if we add 2 plus 3, what is the result? 5. If we add 3 plus 2, that is, order is changed. What is the result? Yes, 5. That is, if we change the order, the result will not change. That is, the result is same. So addition is satisfied for commutative property. Next comes associative property. Associative property. Grouping integers differently does not change the sum. What it means? Grouping integers. For example, if we group I1 plus I2 plus I3 equal to what? I4. When we add I1 to I2 plus I3, what is the result? Again I4. That is, if we group two integers, the result will be the same. For example, we add 3 plus 2, it's a group, plus 1 is equal to 3 plus 2 what? 5. 5 plus 1 what? 6. Again we add 3 plus 2 plus 1. Okay, what is the result? Here 6. means grouping does not affect the result of addition. Grouping integers differently does not change the sum. Okay. Then comes identity property. Adding 0 to any integer, that is additive identity. So additive identity. Adding 0 to any integer leaves it unchanged. For example, if we add I1 to 0, what is the result? I1 itself. For example, if we add 3 to 0, what is the result? 3. Another example, if we add 2 plus 0, what is the result? 2. That is, adding 0 to any integer leaves it unchanged. Okay, all clear? Then comes properties of subtraction. Closure property, non-commutative property, and non-associative means subtraction is satisfied for closure property. Okay, let's move into an example. If we want to subtract 2 from 3, what we get? 1. That is, if we subtract an integer from another integer, we get what? An integer as a result. Okay, that's subtraction. Subtracting integers always gives another integer. Let's look. Subtraction is commutative or not. Changing the order affects the result in the case of subtraction. Here, if we want to subtract 2 from 3, we get what? Yes, 1. But when we change the order, -2, -3, what is the result? -5. The result changed. So, we can conclude that changing the order affects the result, and so the subtraction is non-commutative. Then comes non-associative, means grouping differently changes the outcome. Okay, let's look into an example. If we subtract -2, -3, -5, okay, what is the result? -2, -3, -5, -5, what is the -10 we get? Again we subtract -2, -3, -5, but we change the grouping. -2 minus of, what is 3 minus 5? -2. Okay, then what is the result? -2 plus 2 we got, and the final result is 0. Here we get 10 and here we get 0. That is, if we change the order, the result will not be the same. So we can conclude that in case of subtraction, it is non-associative. Okay. In general, we say that closure property is satisfied for both addition and subtraction. Okay. Commutative property is satisfied for addition but not for subtraction. And associative property is satisfied for addition but not satisfied for subtraction. Okay, clear? That's all about today's topic. See you all in next class.